Prepare to be thrilled as we embark on an exhilarating journey through SpaceX's latest marvel, Flight 4 of the Starship. From its fiery ascent to the seamless touchdown, every moment was a spectacle. But the real story begins where the rocket first soared skyward. Join us at the heart of the action, Starbase Launchpad, where the magic of engineering meets the harsh reality of space travel. Today, on Tech Trend Whisperer, we uncover the aftermath of the launch and delve into the significant advancements and daunting challenges the Launchpad faces. What secrets does it hold? What improvements are in store for the next flight? Stay tuned as we explore these intriguing questions and more, bringing you closer to the future of space exploration. From high camera angles, we once again witnessed the remarkable scenes created by SpaceX's Starship. This flight marked a significant milestone with the successful landing of both Starship stages for the first time, setting the stage for many subsequent strides. The Launchpad played a crucial role in making this possible. Post-flight images of the Launchpad have surfaced showing that overall, there was no significant damage to the launch system. The legs of the orbital launch mount, or OLM for short, and the protective wall between the OLM and the launch tower only have slight scorch marks, which is expected with any rocket launch. The area with the heaviest burns appears to be at the top of the protective wall, which has turned to an ashen gray. Notably, during this recent flight, the rocket lifted off quite slowly, subjecting the Launchpad to prolonged heat, pressure, and thrust. Regarding the OLM, aside from the basic structure, the parts added and upgraded before Flight 4, such as the booster quick disconnect, QD covers and fuel hoses, also showed no issues. These components sustained significant damage after Flight 3, prompting SpaceX to replace the fuel hoses and BQD covers and upgrade the motion mechanism. As a result, the liftoff process went smoothly, ensuring the safety of all elements. Additionally, the holding clamps replaced before Flight 4 have also performed reliably. Looking up at the launch tower, the chopstick system appears to be functioning well after the launch. It was lowered for further inspection by the workers, but overall, the chopstick system won't need any major repairs. Meanwhile, the surrounding infrastructure, especially the tank farms, remained unaffected by the flight. This is largely due to SpaceX's substantial upgrades to this system, replacing most of the vertical tanks with horizontal ones. These changes not only enhance safety but also improve efficiency in the fuel loading process, reducing the average time from about an hour to 45 to 50 minutes. However, we can't say the Launchpad performed perfectly as some systems still showed issues. For example, at the OLM, the water deluge system, while functioning well, revealed a significant problem after enduring the thrust of over 7,000 tons during 3 consecutive flights. Post-flight images showed the steel plate had turned yellow. This discoloration is likely due to the intense heat from the engines which overheated the steel plate and altered its color. The water-cooled steel plate added below the OLM after Flight 1 and first used in Flight 2 has proven to be reliable during launches and tests. However, after just 3 flights, it has shown signs of wear, indicating that SpaceX may need to modify or replace it to ensure the Launchpad's long-term operation, possibly enduring hundreds or thousands of launches. SpaceX will need to use steel plates with excellent resistance and stable performance on the launch tower. We once again see issues with the ship QD. In previous flights, this part has frequently been misaligned due to the strong vibrations during liftoff. As the lightest and most vulnerable part of the launch system, these problems are understandable. After each flight, SpaceX has adjusted the position, increased the contact angle, expanded the operating range, and more. However, these changes still seem insufficient to bolster the ship QD's resistance to the powerful rocket launches. A little side information. The recent flight also had some impact on the surrounding area. Some sources reported that the extremely strong vibrations and numerous small pieces of debris from the launch affected local wildlife, particularly birds, causing their eggs to break. Additionally, on June 4, a Texas environmental group called Save RGV announced a lawsuit against SpaceX for violating federal law, including clean water issues related to the water deluge system. These are pressing issues that SpaceX needs to address promptly. The environment is a sensitive topic and has been a challenge for SpaceX since their arrival in Texas. Beyond technical upgrades, SpaceX likely needs to implement solutions to mitigate these environmental impacts and avoid unnecessary conflicts. Of course, the focus of the upcoming upgrades will be to prepare for Flight 5. First, they will need to reinforce the water-cooled steel plate, not just to ensure the safety of the next flight but also to create long-term operability. Details on the OLM, such as the booster QD and clamps, also need to be monitored closely. Protective walls must be evaluated and strengthened if necessary. On the launch tower, The ship QD needs a comprehensive upgrade to resolve the issue of constant tilting after each flight. However, the most critical system requiring attention is the chopstick. It will play a key role in the next flight by catching the first booster as it returns to Starbase. This system needs to operate with extreme precision and stability, coordinating seamlessly with the booster's navigation and acceleration to ensure a safe landing. Successfully achieving this will mark a significant milestone in Starship's development, demonstrating SpaceX's ability to land and reuse rockets. It'll also validate SpaceX's choice of using the chopstick system over other potential solutions. In addition to upgrading the current launch tower, SpaceX will also be advancing the construction of a new launch tower in the coming months. Many believe that having a second launch tower will significantly increase the success rate of landing boosters or even both stages of the rocket. A second tower will ensure that SpaceX is always prepared to catch Starship stages, even if the previous launch tower is not ready or experiences an issue. The first portion of the new chopstick system and the final tower segments are currently on their way to Starbase. While the exact design of the new tower is not yet known, Musk recently revealed that the tower will be robust enough to handle thousands of landings. He also mentioned that the tower is actually taller than Mechazilla from the movie, so giant Mechazilla arms catch this gigantic rocket. It is truly exciting to anticipate the new designs of the launch tower. Do you think it'll be different from the current one? Will it be completed in time to be used on the upcoming Flight 5? Please let me know with a yes or a no, and be sure to add your explanation in the comments section down below. So, we've discussed Starship landing expectations extensively. Now it's a good time to shift our focus to the landing story of another remarkable rocket, the Falcon 9. Since its first successful booster landing in December of 2015, SpaceX has continuously set new records for this maneuver. Recently, they achieved yet another milestone in this area that they are mastering. Specifically, on the evening of June 7, SpaceX launched the Falcon 9 from SLC-40 to deploy 22 broadband Starlink satellites into orbit. Liftoff occurred at 9:56 p.m. Eastern Daylight Time. Approximately 8.5 minutes later, the first stage of the Falcon 9 returned to Earth as planned, landing vertically on the SpaceX drone ship, a shortfall of Gravitas, stationed in the Atlantic Ocean. Meanwhile, the Falcon's upper stage continued carrying the 22 Starlink satellites to low Earth orbit, deploying them 52.5 minutes after liftoff. This launch marked the 59th orbital mission of the year for SpaceX. Impressively, it was also the 16th launch and landing for this particular booster, as stated in SpaceX's mission description. Notably, 12 of these flights have been dedicated to Starlink missions. However, the standout achievement of this mission is that it represents the 300th landing of the Falcon 9 rocket. Following the successful landing, SpaceX announced, Falcon 9 lands for the 300th time, marking a significant milestone in the rocket's remarkable journey. This is undeniably a remarkable milestone that SpaceX has achieved. Beyond simply launching more rockets, SpaceX has demonstrated its exceptional ability to reuse rockets effectively. This capability not only saves a significant amount of production costs, but also reduces mission turnaround time. Currently, Falcon 9 boosters have reached a peak of 21 reuses per 40 landings, highlighting SpaceX's commitment to sustainability and efficiency. These achievements set SpaceX's rockets apart from others in the industry and underscore the comprehensiveness of SpaceX's rocket system. As of June 8, SpaceX has completed 60 Falcon 9 launches, with approximately 88 missions remaining for the year. If Falcon 9 continues to achieve successful landings on all these missions, it is projected to approach 400 landings by the end of 2024. Perhaps, sometime early next year, we'll reconvene to discuss Falcon's new record of 400 landings. With this wealth of experience, SpaceX can leverage its expertise to enhance the capabilities of Starship. I firmly believe that Starship will deliver even more impressive landing scenes, achieve unprecedented milestones, and unlock greater potential than the Falcon 9. But it all begins with the upcoming Flight 5. So, let's eagerly await the journey ahead. In this thrilling episode of Great SpaceX, we delve into the aftermath of SpaceX's Starship Flight 4, examining the critical role and condition of the Launchpad from which this innovative spacecraft took off. We explore the significant milestones achieved during this flight, including the successful landing of both Starship stages, a first in SpaceX's history. This episode provides an in-depth look at the Launchpad's performance, highlighting the resilience of the water-cooled steel plate and the chopstick system, despite facing intense heat and mechanical stress. We also discuss the ongoing enhancements to the launch system, particularly the upgrades to the booster quick disconnect covers and fuel hoses that were instrumental in the smooth execution of the flight. Despite these successes, we uncover challenges such as the slight misalignment issues with the ship quick disconnect, QD, and the environmental impacts on local wildlife, spurred by the intense vibrations of the launch. Looking to the future, we outline SpaceX's plans for upgrading the Launchpad to prepare for Flight 5, with a special focus on reinforcing the water-cooled steel plate and the critical chopstick system for catching the first booster. Additionally, anticipation builds around the construction of a new launch tower, promising to enhance the success rates of future landings. This episode not only showcases the technological feats of SpaceX but also addresses the environmental and mechanical challenges they face, illustrating the dynamic interplay of innovation and sustainability in the pursuit of space exploration. Join us as we continue to follow SpaceX's journey, pushing the boundaries of what's possible in aerospace technology. Well, folks, that's about it for today's episode. Thank you so much for tuning in, and as always, this has been Kevin from Tech Trend Whisperer. Until next time, keep looking up.